Good morning, my dear students. My name is Dr. K.C.H. Apparao, working as an associate professor in mechanical engineering department. Today, I would like to explain about critical thinking questions on dimensionless analysis. Okay, in last class, we discussed the uh, what is the significance of dimensionless numbers. Dimensionless numbers nothing but Reynolds number and Prandtl number, Grashof number and Nusselt number. We saw already in last class what is the significance of those numbers, what is the importance of those numbers. Okay, so in this class we will see what is the importance of dimensionless analysis, because we are discussing the question bank questions. Important to critical thinking questions in question bank. Okay, so in the question bank, this type of questions has been given, like what is the significance of dimensionless analysis for study of convection process. So this is the one question. Another, using Buckingham pi theorem or pi dimensional analysis, derive an expression for heat transfer coefficient for forced convection. What are the variables given in forced convection, given here in forced convection, which are related to forced convection. So we will address these questions in this presentation. First of all, we will see what is the importance of dimensionless analysis. Why you have to study about dimensionless analysis. Okay, in last class already discussed this one. Studying of convection process, particularly heat lost by convection, both natural convection or forced convection. So it is extremely complex process and controlling variables are numerous, because the fluids, it means convection takes place only in fluids. In fluids also, bulk movement of the particles are completely or significantly associated with the convection process. It means without movement of the particles, we cannot perform convection process. We know this one. But fluid particles or fluid has different characteristics or different fluid properties. We already discussed like density, viscosity, dynamic viscosity, kinematic viscosity, velocity, and surface tension, thermal conductivity, and many parameters are there. Okay, so it is very difficult to study the effect of each variable in this process. Okay, so for this one, just like we have to combine these variables into some dimensionless numbers. Okay, so one thing, but it is possible to investigate experimentally and express scientifically by the result for one geometrical configuration using that dimensionless or dimensional analysis. By using the dimensional analysis, we can study this one experimentally and express this scientifically also, because this dimensionless analysis combines these properties into or converts these properties into some dimensionless numbers. We already discussed the dimensionless numbers: Reynolds number, Prandtl number, Nusselt number, and Grashof number. By using these numbers, we can study the convection process easily. Okay, the major advantage of dimensionless analysis is to reduce the number of variables in a problem with the help of dimensionless analysis, because we can combine the variables of the problem into dimensionless groups or dimensionless numbers. Dimensionless groups or dimensionless numbers nothing but Reynolds number, Prandtl number, Nusselt number, or gross of number. By using these numbers, we can easily understand the process of convection. Okay, the main advantage of dimensionless analysis is to reduce the number of variables in a problem with the help of dimensionless analysis, and we can combine the variables of the problem into dimensionless groups. Conversion of the variables into dimensionless groups such as Reynolds number, Prandtl number, Grashof number. So by using these numbers, or by using these dimensionless numbers, we can easily understand the conversion process. So how to convert these variables into dimensionless numbers? We'll see what is the process, what are the different methods used in dimensionless analysis to reduce the number of variables of the convection process into dimensionless groups like Reynolds number, Prandtl number, or Grashof number. We'll see. So it is a mathematical method. Dimensionless analysis is nothing but a mathematical method in which physical quantities expressed in terms of their fundamental dimensions. So physical quantities like expressed in their fundamental dimensions. The fundamental dimensions such as mass, length, time, and temperature. So these are the very fundamental dimensions. So all the quantities are expressed in terms of these fundamental dimensions. Next, this such method is known as a principle of dimensional analysis. We'll see what is the method. So this method can be applied to all types of fluid resistances, heat flow problems, and many other problems in fluid mechanics and thermodynamics also. This is the main application of dimensionless analysis. The equations produced by this method also gives non-dimensional constants which govern the problem under consideration. So these non-dimensional constants are very important in engineering practices. So we'll see what are the methods. Okay. So dimensions and units. First of all, we'll see some basics which are related to dimensional analysis. A dimension is a type of physical quantity. We know that. A unit is a means of assigning a numerical value to that quantity. We know this. So SI units are preferred in the scientific works. So these are the basics. So primary dimensions, we will see. What are the primary dimensions? In fluid mechanics, the primary fundamental dimensions are, first one is the mass, it is represented by M. Length is represented by L. So these are the fundamental dimensions. Time, it is represented by T. Temperature, it is represented by theta. Okay. So mass is kg according to SI units. Length, meter. Time is the second. Temperature is the Kelvin. Okay. In other areas, just to these are the additional dimensions. You can see like current to luminous intensity and the amount of substances. So this, so we probably will use this basic fundamental dimensions in our problems. So these are the different dimensions of different parameters or variables: area, volume, moment of inertia. So we can, area means length into length, L square, the dimensions is L square, volume L cube, moment of inertia, so Mi. So that is the units is L to the power of 4. Okay. Acceleration. So acceleration means, you know that velocity by time. Velocity is equal to distance by time. So that is LT minus 1. Acceleration, velocity by time. So LT minus 2. Angle is 1. Okay, dimensionless. Angular velocity T to the power of minus 1. Similarly, force F is equal to MA. So mass is the M, and the acceleration LT minus 2. So MLT minus 2. These are the, so all the dimensions, all the variables are represented into basic dimensional values. Okay, or mass, length, time. Okay, so power is equal to force upon time, just like okay, so the value is equal to m L square t to the power of minus 3. Next, pressure. So P is equal to m L minus 1 t minus 1. Density, mass upon volume. So volume mass is equal to m, volume is equal to L cube. So m L cube, so minus 3. It means all these variables can be represented, the dimensions of these variables can be represented by basic fundamental dimensions, that is nothing but mass, volume, mass, length, and time. Okay, so these are the values. Now we'll see some example for understanding of dimensions. So use the definitions. Okay, you know that tau shear stress is equal to mu into du by dy to determine the viscosity. So viscosity, you can understand for this finding of the viscosity. So conversion of dimensions of the viscosity. This is the dynamic viscosity. Then viscosity is equal to tau into du by dy by du. Okay, so tau upon du by dy, you can write like this one. Tau is nothing but force upon area, by du is the velocity, by length. Okay, so force is nothing but ml t minus 2 by area L square, by velocity lt minus 1, by length L. Okay, if you simplify this one, you will get m L minus 1 t minus 1. So in this way, just like we can convert the these values, these variables, these property of the fluid into basic dimensionless numbers. Basic dimensions are basic parameters. Okay, so this way. Alternatively, dimensions may be reduced indirectly from any known formula involving the quantity. So here Reynolds number, Re is equal to rho ul by mu. It is the dimensionless number. So the dimensions of mu must be same as the rho ul, because so Reynolds number, we know that in last class we already discussed this one. Reynolds number is the dimensionless number. Nusselt also dimensionless number. Prandtl also dimensionless number. Grashof number also dimensionless number. You know this one, Reynolds number formula in last class we discussed rho ul by mu. Otherwise you can write like this one, ul by mu, the kinematic viscosity. It means the dimension of this one and ul the same. So then we will get the dimensionless number, or dynamic viscosity is equal to rho ul. So this dimension is equal to this one. So then Re is the dimensionless number. Okay, so similarly Nusselt is the convection of the HL by K. Okay, HL dimensions is equal to thermal conductivity dimensions. So then we will get Nusselt is the dimensionless number. So we can convert these parameters or variables, or we can reduce these parameters into dimensionless numbers. How to carry on this one, we will see. There are few methods to convert or to reduce the different variables of fluids into dimensionless numbers. So one is the Buckingham pi theorem. We will see what is the basic functioning, or what is the process of the Buckingham pi theorem. So if a problem involves n relevant variables, so here variables are relevant variables are n. Okay, so in which we understand that m is the independent dimensions. Okay, like this one. Then it can be reduced to relationship between the n minus 1 terms. So then we can choose, or we can identify the n minus 1 terms, pi 1, pi 2, pi 3. Okay. If you know that variables, n variables, and you have to identify the independent dimensions, then you can find out the number of terms. Okay. So to construct these non-dimensional pi terms, okay, pi groups or dimensionless groups, how to, first of all choose m representing the variables, not representing, n is the variables, m is the repeating variables, m is the repeating variable. Okay, so it is based upon the geometry or velocity or flow. Okay, so for n, for each n minus m, so this is the process or process of Buckingham pi theorem. So first you have to identify the repeating variables in this one, in the n variables, in the total variables. That we have identification of repeating variables is depend upon geometry, velocity and flow. For each of the pi terms, it means n minus m remaining variables. So for each of n minus 1 remaining variables, construct a non-dimensional pi of the form. It means pi 1 is equal to, first we will see remaining variable, what are the variables are, except these m value repeating variables. So remaining variables, you have to take the first variable, then take the repeating variables, scale 1, you have to take the powers ABC, next to scale 2, power B, scale 3, power C. So these are the repeating variables, these are the remaining variables. So remaining variables in each pi term, we have to take the remaining variable every time. So if you suppose, we will see, we can understand this problem by one example. So this is the process. Construction of pi terms is equal to first variable, these are the repeating variables. It means so m is the repeating variables, you can say. ABC, so they are chosen to as to, for the powers are taken to solve that problem and to find the pi value. Okay, we'll see. So Buckingham pi theorem that says the number of independent dimensionless groups that can be formed from a set of n variables. Okay, so n variables, we have to identify the m basic dimensions, then n minus m is shows the pi terms. Okay, for example, a1, a2, a3, a4 and a6 are the relevant variables. These are the n variables in this problem, and in these 6 variables be expressed in terms of 4 basic dimensions. So either mass, length, next time and temperature. So we have to identify the basic dimensions. The number of independent and dimensionless groups that shows the, so total number n minus basic dimensions m is equal to, so 6 minus 4 2. So we have to create, we have to convert the these variables, n variables, into 2 dimensionless groups. Okay, so these dimensionless groups are represented by terms pi 1 and pi 2 pi terms. Okay, so we'll see an example here, then you can understand properly. So these are the variables given here, r and L the velocity, and mu density, rho viscosity, dynamic viscosity, rho is the density, k is the thermal conductivity. Okay, so 6 variables, these are n variables, n is the 6. Okay, in which you have to identify the basic dimensions. So basic dimensions are here, just like you can take length is the basic dimensions, based upon the geometry, based upon the velocity, and then length we can take, and the velocity also we can considered as a basic dimension, and rho is the related to mass, viscosity, so density. Okay, so this one also basic dimensions. Here we identify this one, L length and velocity basic dimension, and density mass upon volume ml cube. Okay, so we identify these three as a basic dimensions. Okay. So then basic dimensions are 3. Total is 6. 6 minus 3. So here pi temps is equal to 3. So pi 1 you have to find out, pi 2 you have to find out, pi 3 you have to find out. So here we can find out the 3 dimensionless groups or dimensionless numbers. Okay. So we'll solve this or we'll solve according to question bank. We will solve this forced convection process by using the dimensionless analysis. We know that forced convection process Nusselt is equal to it is the product of Reynolds into Prandtl number. Okay, so finally here we will see 3 dimensionless number. One is the Nusselt dimensionless number, and the Reynolds dimensionless number, and the Prandtl dimensionless number. It means so from this numerical we will get to 3 dimensionless groups. One is pi 1 is the something Reynolds, pi 2 is the Prandtl number, and pi 3. So 3 times we will get Nusselt dimensionless number. We will see how to solve this one quickly. So these are the parameters or variables given in the forced convection. You know that forced convection parameters, that is the fluid density and dynamic viscosity and fluid velocity also given. Next to thermal conductivity K, and specific heat of the fluid also given. So characteristic length of the heat transfer area, so that is D. So in case of circular pipe, that is D. In the flat flight, so that one is the L. Okay, so you know that dimensions of these variables: density, mass upon volume, ml cube. So viscosity, so viscosity is equal to, you know that dimensionless value ml minus 1 t minus 1. Fluid velocity is equal to distance per time lt minus 1. Thermal conductivity, you know that one, watt per meter square meter Kelvin. So we apply this, then we will get. Okay, so this is the K is the temperature. So ml minus 3 into t minus theta minus 1. So this one shows the temperature. So next to specific heat, L square t minus 2 theta minus 1. Next to characteristic length, that is the length. By using dimensions, we can convert these 6 variables into 3 dimensionless groups. How to convert these variables into dimensionless groups, we will see. So these are the given variables. So n is equal to 6 we can take. Then you have to identify the dimensionless basic dimensions. We are considering so heat transfer coefficient also you have to consider. So we have to find heat transfer coefficient. So if you include this heat transfer coefficient, then n value, number of variables n is equal to, so 6, not 6, 7. Okay. Then here we have to identify the functional or fundamental units. What are the fundamental units? Here we can identify these fundamental units is equal to m is equal to 4 here. Then pi terms or dimensionless group numbers is equal to 7 minus 4 is equal to 3. So pi 1, pi 2 and pi 3. It means Reynolds number you have to derive, Prandtl number and Nusselt number you have to derive this one. So how to find this one? We will see. First term, pi term. So pi 1 is equal to, we are taking that 4 dimensionless basic fundamental dimensions, that is viscosity, dynamic viscosity have taken, that is the fundamental dimensions. Next to thermal conductivity has taken, so representing the temperature. Okay, that one. Next, velocity and diameter. So these four are dimensionless fundamental dimensions. So these four fundamental dimensions will be repeated in all pi terms. So along with, you have to take the remaining variables. The first remaining variable is the h. Okay, here. So this is the basic. This one also velocity, basic one. So viscosity also basic. You have to take it. Thermal conductivity, you have taken the basic dimensions. So along with h. Okay, first h, mu to the power of a, and v to the power of b, and k to the power of c, and d to the power of d. So you have to take, these are the repeating variables. Along with, you have to take the remaining variable in each term. So here h, next to you have to cp, next to rho, the density you have to take cp, ua, and vb, and kc, and d to the power of d. So similarly, rho into mu a, and vb, and kc, and d to the power of d. So by using these pi terms, we can find the values. Okay, first one, first pi terms, mu a and kb and v to the power of c, d to the power of d, h. So you know that initially you will take m to the power of 0, l to the power of 0, t to the power of 0, and theta to the power of 0. Then you know that thermal dynamic viscosity dimensions ml minus 1, t minus 1, and ml for the thermal conductivity, ml t minus 3 and theta minus 1. For temperature, you have to take this k as a basic dimension. Okay, so similarly, velocity lt minus 1, diameter, the length L minus 1. Last is the heat transfer coefficient m t minus 3 theta minus 1. So here powers ABC. By using these powers, you can solve the, you can find out the A value and B value, because first you have to take with respect to mass, then you can equal the powers, then compare the powers of the length, then you can find out the equation, then compare the powers of the temperature and compare the powers of the theta, then you can find out the ABC values, then you will get the final formula. So these are the solutions. You can solve this one. Then we got this final term, we got this pi 1 is equal to mu to the power of a value is equal to 0 and k to the power of minus 1. So b value is equal to minus 1, v value is equal to 0, and d value is equal to 1 into h. So the final pi 1 is equal to hd by k. So hd by k or hl by k, you know this formula, this is nothing but Nusselt value or Nusselt dimensionless number. Okay, if you next you can solve the pi 2 term. If you solve this one, you will get that the value pi 2 is equal to rho vd by mu. Rho vd by mu or vd by mu. So this is nothing but Reynolds number. We already discussed in last class. So first one, pi 1 is the Nusselt number. So pi 2 is the Reynolds number, and pi 3 is the Prandtl number. Okay, so we can see the relationship these things. Okay, so Nusselt is equal to the pi of just multiplication of Reynolds and Prandtl. So in this way, just we can convert 7 variables into 3 dimensionless groups. By using these dimensionless groups, we can study the convection process, mainly forced convection process. Okay, so these are the different textbooks we can refer to understand and solve the different dimensionless number problems. So few more numericals we'll see in next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.